Welcome to this tutorial. I'm solving question number 7 of paper 2-1 October-November exam series of 2019, and the topic of this question is isotopes and the half-life. Question says table 7.1 shows the composition of 4 neutral atoms and 1 atom that has been ionized. So we have a total of 5 atoms here. 4 of the atoms are neutral atoms and 1 of the atom has been ionized. These 5 particles are labeled as P, Q, R, S and T, and this is the table 7.1. The charge on an electron is minus 1.6 10 raised to minus 19 coulombs. So the quantity or the amount of charge of one particle is given here, which is electron. State which of these 5 particles is the ionized atom. So in a neutral atom, number of electrons and number of protons are always the same. So for P they are same, for Q they are different. We have one more proton than the electrons. For R they are same, S 19 19, and for T they are 20 and 20. So only Q has different number of protons and electrons. So the answer for this part is Q. Q is the ionized atom. State the size and the sign of the charge on the ionized atom. So since we have one more proton than the electron, so the positive charge is going to dominate. The sign of the charge is going to be positive, and the quantity of charge would be equal to the same as the charge on one electron for a proton. So positive 1.6 10 raised to minus 19 coulombs would be the answer for this question. State which pair from P, Q, R, S and T are isotopes of the same element. So for being the isotope of the same element, there should be same number of protons but different numbers of neutrons. So we have 19, the proton number for Q, and again 19 for the proton number of S. We have 23 neutrons here in S but 20 neutrons in Q. So these two particles are the isotopes since they have same number of proton but different numbers of neutron. S and Q are the isotopes. One of the atom is a radioactive isotope that decays to produce one of the other atom. Deduce which atom decays in this way. So the atom decaying in this way is this particle R, because when R decays, its proton number increases by 1, so 18 becomes 19, and the number of neutrons are decreased by 1, so 24 becomes 23. And this happens when a beta decay occurs. In a beta decay, we know that a neutron decays and changes itself into a proton and an electron. This electron is emitted as a beta particle. Proton becomes and remains the part of the nucleus, so the proton number increases by 1, and since one neutron has decayed, so the number of neutron decrease by 1. So we would write the answer here as R. R is doing this thing, that it is decaying and converting into another atom. Deduce which atom is the product of this decay. So the product of this decay is S over here according to the given data. Deduce which type of radioactive decay occurs. So here we would say that beta particle emission is taking place. A neutron is basically converting into a proton and an electron or beta particle. The half-life for this radioactive decay is 33 years. So the half-life of this decay is given. A radioactive sample contains a large number of the atoms that decay in this way. Determine the fraction of this number of atoms that will decay in 99 years. Okay, so in 99 years time, how many half-life would be there? So for determining the half-life, I'm dividing 99 by 33. So it means that 3 half-lives would have gone by. Okay, now the next thing is how much radioactive sample would be remaining. So it would be 1 upon 2 raised to n, or 1 upon 2 cube, which is equal to 1 upon 8. So it means 1 upon 8 of the total atoms would be remaining after 99 years. Because every half-life, the quantity becomes half as compared to the starting point of the half-life. Now, the fraction or the quantity that would have decayed, could be found by subtracting the remaining quantity from 1. So 1 minus 1 upon 8 would give us 8 minus 1 equal to 7 upon 8. So this is the quantity which has already decayed in 99 years, and this would be the answer here. So we would be writing 7 upon 8 is the quantity and the fraction that has decayed. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.